Hello, my name is Darren Kosinski. I'm an engineer on the FireMonkey team at Embarcadero. Today I'd like to share with you some of the new things that have been added to the FireMonkey framework over the past year or so. We've continued to enhance our support for Windows, Mac OS X, and iOS, and in RadStudio XE6 we added support for Android devices, including phones, tablets, and Google Glass. These are a lot of platforms to support, with a lot of differences in the look and feel between them. One of our top goals over the past year has been to find ways to make it easier for you to write apps that can target all of them. We've added platform default behaviors that let controls change their size and position based on the device they're running on. We've created a new variant of form inheritance that we call Delta Streams that can apply modifications to a form based on the runtime device. This is the core technology that is at the heart of the FireUI designer. All of these concepts come together in a new transforming supercomponent called T-Multiview. We've also added some new platform services to make it easier to save and restore application state and to write diagnostic information to system logs. For edit controls, we've added an option of using a native presentation of the control for iOS. This provides greater performance and fidelity on iOS while still allowing the development of multi-platform code. There's a lot more that's changed too, but this is what we'll have time to cover today. Let's take a look at these in a little more detail. Between iOS, Android, Windows, and Mac OS X, many controls have different sizes. In RadStudio XE7, we wanted to introduce the idea of an abstract size so that a component could automatically get the right size for the runtime device. We introduced a new size property on the FireMonkey T control. Instead of just being a collection of scalar values, the size property is a T-persistent object that has a property called platform default. When this is enabled, it makes the component automatically resize based on the runtime platform or the platform properties of the view selected in the designer. The old width and height properties still exist, but they set and retrieve their values from this new T-control size object. When you drop a new component on the form, the platform default property is set to true. When you resize the component, either in the designer or in code, it automatically turns off the platform default setting so that the component keeps the size that you designed on all the platforms. We also added a new value to the tab position enumeration for the T-tab control. It's called platform default. For new tab controls, this is the default setting. When your app is run on most platforms, this setting causes the tabs to be positioned at the top of the tab control. When the app runs on iOS, the tabs will be positioned at the bottom of the tab control. Let's take a look at this. So this is just a FireMonkey form with a tab control, a few tab items, and a button. Let's look at the button. If we look at the property inspector or object inspector, see we have this size property now, which is of type T-control size. It has the height and width, and it has the platform default setting, and it's set to true. Now let's try adding a, let's add say an Android 5-inch phone view onto this. So a few things have happened here. Of course you get the Android appearance, but if we look at the button, let's come and look at the size again. You can see that the height and width have changed. Platform default is still set to true, but this is the standard size, the default size of a button for the Android platform. And if we do something, let's add a, say a 4-inch iPhone view. And now a few other things have changed here. The button, since there's no outline, it's a little harder to tell the size, but if we look here, we can see that it's also different from the master view. but it has platform default set to true. But another thing that's happened is you see that the tab controls, that the tab items have moved to the bottom of the tab control. If we come back to the Android view, you see they're at the top. The iPhone view, they're at the bottom. And if we look at the tab control, see the tab position property, and you see that's set to platform default. Let me come back to the master view, and on the tab control, so you can still, of course, lock it to top or bottom position as you like, but if you set it to platform default, which is standard for a new tab control that you drop on a form, then it will automatically change the view based on the runtime platform or the view that's selected in the designer. So let me show you a little bit. Let me add another button here to the form. So this is a new control that was dropped, which of course means the platform default setting is true. But now let's resize it. Say this button, I want this button to be a large button for whatever reason. And if we look, you see that the platform default is now true, and the size is set to how we sized it in the designer. And if we come over to the Android view, you see it's also maintained that size, the size that we defined for it. Again, platform default is set to false. If we come back to the master view, and if this resizing was an accident, if, for example, we clicked on the corner and dragged when we didn't really mean to, we can come back here, set the size back to platform default, and it will resize the control to the default size. And if we look here on the Android view, you see that it's also been changed back to the default size. Now the platform default is set to true. So that's a look at some of the platform default behaviors that we've added. It lets you design a form and have the control size to what's appropriate for the runtime platform, and also to reposition the tab control, the tab items, based on the runtime platform. So in that last demo, you saw a little bit of the FireUI multi-device designer. And I'm sure you've seen some of the other videos and demonstrations of FireUI. You saw how you can add views for different devices to a form. And I want to show you now how this works behind the scenes and some of the things it means for you as a developer. For a long time, Delphi and C++ Builder have had a feature called form inheritance. Form inheritance allows you to create a new form which inherits all of the components, properties, and events from an existing form. We've adapted the form inheritance technology to create a mechanism called delta streams. With this mechanism, a form is composed of two separate streams, a master stream and a stream which contains the differences or deltas from the master. Each of these delta streams are stored in their own FMX form file and referenced in the unit as resources. A unit can have several delta streams associated with it, and the runtime will use device detection logic to pick the best one to use. One key difference between delta streams and form inheritance is that there's just a single form class that's used for all of the views. So that means all of the device views will have the same set of components on them. But you can choose to show and hide some of them on different views. It's probably a little easier to show this in code, so let's walk through a demo. So here we have a FireMonkey project. We have just a FireMonkey form, and I've created a couple views, Android 5-inch phone and an Android 7-inch tablet. add a couple controls here. Let's add a couple buttons and edit. Over here like this. We can see that those controls propagate to the views. Let's say on the 5-inch view, button 2 is not applicable. So let's set button 2 on the 5-inch view, and let's set the visible to false. If we look at the master view, it still has the 2 buttons. 7-inch tablet still has 2 buttons. 5-inch view, the second button is hidden. Let's take a look at the form. What you see looks a lot like what you would expect to see with form inheritance on an inherited form. Now it has the keyword inherited here, and you see that here we have inherited button 2 and visible is false. So these are the differences in this view from the master view. And it's very similar to what you would have if you were to look at the differences between an inherited form and the original form that it came from. Go back to the form. How does the runtime know about these views? Because each of these are separate form files. Let's take a look in the unit itself, because you see there's only one unit. There's unit1.cpp, unit1.h. There's no separate piece of code, and that's the difference from what you would have in form inheritance. In form inheritance, your inherited form would have its own unit. But here we have the resources that the runtime uses for loading the form resources when the form is created. We have the resource for the master view. This is the same form resource like what you've seen since the beginning of FireMonkey. And then there's these 2 other resources that have these kind of funny looking names. These are the delta streams. These are the streams, the different streams for the views that were defined in the project. And these names are special. And I need to show you a bit of Delphi code because this is defined in the Delphi RTL. We have this unit, system.android devices. There's a similar unit called system.iOS devices that defines things for iOS. But we define all of these special names, and each of these names corresponds to a form factor of a device. You see there's quite a few of them here. Whereas in the designer, we have 6 Android devices here. We come back here to system.android devices. You'll see down here that we actually only register 6 of them. And these correspond to the ones that you see in the designer and the views dropdown. We've reserved all of these for future use as new devices come out. There's a lot of things here that may get activated that we need these different definitions to support. But right now, 6 devices pretty well covers the Android ecosystem. So each of these device definitions defines things about the device: the logical size, physical size, DPI of the display, so forth. So at runtime, when this form gets created, how does the runtime know which of these to pick? What it does is it calls a method that's on the form called getDeltaStreams. And this is where it's declared in the forms header for C++, but the actual implementation is in Delphi. It's in the unit fmx.forms.pass. And this is the getDeltaStreams method. And what it does is it calls a behavior service. It's called iDeviceBehavior. And it calls this method to get the display metrics. That calls various operating system functions to get the width and height and screen density of the screen that this form is being loaded on. And once it has those metrics, those are passed to this Delphi RTL unit, or a method called selectDevices. And what selectDevices does is it will take these 6 devices that we have defined, and it will put them in order with the best match at the top, the worst match at the bottom, based on how well it matches. And then that ordered list is sent to this RTL method, Delphi RTL method called readComponent Delta resource. And what that does is it tries to find the best match of the resources that are linked in. So if it finds this exact resource, and this is the top listed item, this is the delta stream that it's going to load. So if you're running on a 5-inch or 5.5-inch Android phone, chances are this is the one that it's going to match. If you're running on something that's a little bit larger, it might actually be closer to the tablet size, and this may be the best match. But these resources that are defined in the unit, these are the resources that the runtime has available. So it will go through that ordered list of the 6 Android devices, and it will find the best match of these 2, and it will apply that delta to the master. Now, if the runtime doesn't find a match at all, if these resources weren't there, or it just doesn't find a match, the ultimate fallback is to show the master view. So I hope that gives a little bit of insight about what the delta streams are. That it's really like, it looks very similar to a form inheritance form stream, and how they get loaded by the runtime when the form is created, essentially by creating this ordered list of registered devices and then finding the best match. The platform default behaviors and the use of device-specific delta streams all contribute to our goal of making it easy to develop an application that runs well on any device. One thing that's missing is a device-appropriate way to provide navigation within your app. On a phone, navigation is typically handled with the use of drawers that slide out to reveal options that are really effectively menus. On a larger tablet or desktop app, this is often handled with dock panels. Sometimes these panels contain lists. Sometimes they're buttons. Our answer to this, our solution for this, is a new component that is called Team Multiview. At its base, Team Multiview is a container control, kind of like a panel. It can hold individual controls like buttons, edit fields, list views, or it can host other containers like a tab control. The display and drawing of the panel is abstracted to a presentation class. And we've defined presentation classes for the most common types of displays. We have a presentation class for a drawer, which can either overlay the existing content or push the content aside. We've defined a presentation for a docked panel, and it's also possible for you to develop and register your own presentation object and use that if you don't want to use one of our predefined ones. I think Team Multiview is probably best shown with a demo, so let's take a look at some code. So this is the Multiview demo that comes with Rad Studio XE7. If we look at the form, see that there's a detail panel and a multi-view. And the multi-view is a container similar to the detail panel, and it has 2 components in it. It has a list box and a toolbar. This is a fun demo to play with. If we run it, we see very much what we saw in the form designer. We have the master and the detail. What makes the multi-view really work is these modes that it has. We've defined 3 different modes for the multi-view. It can be a docked panel, a popover, or a drawer. There's also this other mode called platform behavior, which, as you've seen earlier in this demonstration, platform behavior means it's going to pick one of these modes based on some device metrics, and I'll talk more about that in a little bit. If we look at the dock panel, that's like what we see here. And this is the mode that will commonly be used on a tablet or a desktop application. If we look at a popover mode, then we have this button here. It's called a master button. If you click on it, then the panel acts like a pop-up. This is the same panel, the same controls, but it's presented differently. Now if we look at the drawer mode, again, we have the master button, but see now the panel has slid out like a drawer, and the detail panel has become grayed out. And in this case, it was set to overlap, but you can also have it be a pushing where it will push the content off to the side. So these modes, which you can see them here in the object inspector as well, by default it's platform behavior, but we have custom drawer and panel if you want to preset a particular behavior regardless of the device. You can do that. And there's also custom where you can define your own. But each of these modes is an instance of a multi-view presentation. If we look at the code here, you see that we have this class, T-multi-view presentation. And if you look at the Delphi code, you'll see that this is an abstract class. And it defines how the multi-view is going to be displayed. Each of the modes is a concrete instance of this presentation class. Now I wanted to mention a little bit about the platform behavior mode. What that does, I'll have to look at the Delphi code here. It uses a behavior service to get to determine what kind of device it's running on and what the orientation of that device is. And based on that, it will choose which mode it should use. Multi-view. So this is defined in the Delphi runtime of the class. And it gets the class of the device. It uses a behavior service, the T-device info, to get the class of the device. And then if it's a phone, it will choose to use the drawer presentation. If it's a tablet, it looks to see if it's in portrait or landscape orientation. If it's portrait, it will again use the drawer presenter class. And if it's landscape or inverted landscape, it will use the dock panel. And if it's desktop, it will use the dock panel. But that's basically what the different modes are for the multi-view and how it works. And really the best way to get a good feel for the things that the multi-view can do for you is to play around with this demo. So in addition to new components and new platform behaviors, we've added some new platform services to the FireMonkey framework as well. We have a new save state service. This is exposed through the T custom form object through a save state property and an unsave state event. And what this does, is it makes it easy for you to be able to save the state of your application and save the state of a form. For mobile devices in particular, this is important, but it's also relevant on desktop where you may want to retrieve the values that are saved in a form. Another platform service that we've introduced is called the IFMX logging service. And this provides a multi-platform abstraction of writing debug log output. It provides a method that takes a format string and a list of parameters. And on Windows, it shows it as an output debug string, so you will see it in the debugger. On iOS and macOS 10, it writes it to the console, so you can use the console applications to see the debug output. On Android, it writes it to the system log that you can view via ADB. This is really turning creating a service out of some functionality that we've used internally for a number of years. I think both of these are probably best shown through an example. So let's take a look at some code. This is an application that has a form, a tab control. The tab controls, or tab items, have a few controls on them. On the form, we have implemented a couple events. We've implemented a form create event. We've implemented this new form save state event. And let's take a look at that. This event will be fired on desktop. It gets fired when the form is destroyed. On mobile platforms, it gets called when the application goes into the background. And this event gets fired to let you save your state information. And so what I've done in this case is I've created a binary writer, and if there's relevant data to save, at least, I create a binary writer and I just write the current tab index and the text that's in some of these data, the data fields that's on the form. If we look at the form create, it does essentially the opposite. It looks at this new save state property that's on the form, and it looks at the stream associated with it and sees if there's any data in the stream. And if there is data, then it creates a reader. It reads the data from the stream and sets the properties on the various controls. And then I also want to show you this log statement. We have this log D, which will write debugging log information. Let's run the application and you'll see these in action. If we look here in the event log, you see that it shows fresh startup, which is what we have right here, this debugging statement. So that's basically how the logging works. And on iOS or macOS 10, this would show up in the console, and on Android, you'd be able to see this in the ADB logcat output. Let me put a little bit of data in here. And this item just has a memo. And let's just shut down the application. Let's run it again. Well, now you see this debug output is from this message here. And you see that now the second tab item is our active, and it has the text in it. And the same with this tab item, the customer name field has the value in it. So those are a couple new services that have been added to make it easier to save the state of forms during shutdown or when they go in the background, and also for doing some debug diagnostic logging. In RedStudio XE7, we've made a major architectural change to the T-edit controls. We've done this to separate the data model of the control from the view or presentation of the control. This makes it possible to use an actual native control to render and accept input. On iOS, it uses a UI text field. This is the latest and most complete incarnation of technology that we've been working on for several years. You've seen earlier versions of this in the native pickers that we use on iOS and Android, and in concept, much of the T-Multiview uses a similar approach as well. With this architecture, you use the T-edit control as you always have. The properties, methods, and events are the same across all platforms. There's a new control type property, and you can use that to choose a native control for the platforms that support that. For all other platforms, the existing styled presentation will be used. The native presentation is only available on iOS in Rad Studio XE7. Let's take a look at some code. So here we have a form that has a T-edit on it. And if we look in the Object Inspector, we see that there's a new control type property. By default, it's set to styled. But we can change it to be a platform control type. And you see in the designer, it's changed to an outline so that you can resize the edit field and you can design your form around it. But it gives a clear indication that this is going to be a native presentation. Now if you run this on Windows, you will see that it shows up using the same styled presentation that we've always used. So this lets you use the same code to target multiple platforms, but still you have the advantage of having the native control on the platform that supports it, which in XE7 is iOS. So if we look at the edit control, we have T-Custom Edit. And we see that this now descends from a new type. A little more room here. It extends from this new type, T-Presented Control. And if we look at T-Presented Control, so that descends from T-Styled Control. And here you see that this is where the control type enumeration is declared, styled and platform. And this is where the new fields are declared. We have a data model field and a presentation proxy field. The presentation proxy is a class that handles the communication between the FireMonkey T-edit control and the presentation, whether the presentation is the styled control or the styled presentation or the native presentation. And that presentation proxy is declared here in this same unit. FMX controls that presentation. If we look a little bit at the data model, this file fmx controls.model is where the base data model class is declared. There's not a whole lot to it here. This is really a base class. For the controls that implement this architecture, they make a subclass of this. And if we look back at fmx edit, we will see here that we have T-Custom Edit model. So this is the actual data model that's used for the edit control. And then if we look at where the actual native implementation is defined, we have this unit or this class TiOS native edit. This is the actual native presentation of the edit control. And we can see here that it uses the UI text field. The way the native presentation works is that it has a lot of message handlers. And what happens is the data model sends messages to the presentation when various properties are changed. You see things like we have a message for when the check spelling option has changed, when the password, whether it's a password edit field or not. The text settings have changed, the edit button settings have changed. These are all messages that the data model sends to the presentation. When the presentation receives that message, it sets the properties accordingly. In the case of the native presentation, it would set the properties on the UI text field to correspond to these settings. So that shows you a little bit about how this new architecture works. In RadStudio XE7, the T-edit control uses this new architecture. And in the future, we hope to be able to expand this to include more controls and more platforms. That's all the time that we have for today. I've shown you how FireMonkey makes multi-platform, multi-device development even easier by adding platform behaviors for size and position. I've shown you the variant of form inheritance that we call delta streams, which provides the power behind the FireUI designer. I showed the T-multi-view, our new super container component that makes it easy to write multi-platform navigation. The save state service that makes it easy to save the state of your application. And the logging service that makes it easy to write debug information in a platform-independent way. And I showed the new model view architecture of the T-edit control that makes it possible to use a native UI text field on iOS without giving up the multi-platform code compatibility of FireMonkey. Thanks for watching today.
First one by Kevin. Do you have a component that will allow me to create a tree structure and drill down?
Well, we do have a tree view control in FireMonkey, and that's been around for several releases now. You can look in the, there's a FireMonkey's control demo that kind of has several tabs that has all kinds of controls in it, and one of the controls is the tree view.
And there's also on the doc wiki, there's a whole section on TTreeView for fmx.TTreeView and some additional information about a custom tree view class. And then there's a sample that points back to the controls demo.
Right,
yeah.
Exactly.
Yeah. Look for fmx TTreeView. Okay. Typing and talking at the same time, not one of my skills. Sorry. Is there plan to give all components native support? Visual controls, I guess.
Right, sure. We do want to do more controls and more platforms. For RadStudio XE7, we've got the T-edit control for iOS, but the intention is to take the same approach that we've used for that control and apply it to more controls and more platforms throughout the framework.
Okay. Does FMX have something similar to, I guess, Microsoft's WPF, the sort of content presenting versus content and for controls and so on?
No, not really. The move to using the model presenter architecture, model view architecture that we've changed, that we started to use with the T-edit control, would allow something more like that to be done at some point in the future. But in the current release, there's nothing like that.
Sorry for my typing in the background. Okay, let's do that. I'm just typing the terse answers. Let's see. This is an OS 10, I guess, maybe with Yosemite. He's using the Yosemite premium pack that I think Serena blogged, and we uploaded a OS 10 Yosemite saying, are you working on getting OS 10 more pixel accurate to the OS 10 controls? In Yosemite, maybe, or...
Well, I think in every release, we've improved our styles for OS 10, as well as all the other platforms as well. So we try to get closer and closer. With Yosemite, Apple really revamped the entire UI, and so we have new styles that make a FireMonkey application blend into Yosemite pretty well, and we always look to improve those.
Okay, and as always, we always will do more. Okay. If you have other questions, we've got Darren for a few more minutes before he goes back to doing more. I know, Darren, we were doing tests. I've got an iPhone 6, and we did premium styles, and there's some work that's going on for an update, I think, for XZ7 as it relates to making sure we're on the right resolutions. There's some resolutions in the way that apps... Can you explain, because you were trying to explain it to me before, Apple does something where they look maybe at the splash screen resolution, depending on the app you're using or what it was built for?
Yeah, exactly. Because Apple presumes that existing apps or apps that have not been updated in the App Store were made to run on like an iPhone 5 or 5S, the 4-inch screen. So it looks, when the application is launched, it looks at the launch image or the splash screen, and it looks at the resolution of that image. And if it's a resolution that matches the 4-inch iPhone, then it scales the screen automatically. And that's true on both the iPhone 6 and the 6 Plus. So to the application, it thinks it's running on a iPhone 5S, and it thinks it has the resolution of an iPhone 5S. So in a update that we're working on now, we've added some new splash screens for the iPhone 6 and iPhone 6 Plus, so that the Apple application loader will see that, oh, this app has been updated and it has the right resolution, so it doesn't need to scale the screen.
Okay. Yeah, and Darren was giving me test apps to run on my iPhone 6. John Fraser's got a 6 Plus. I don't know if you've given him similar things or want to test, but he got his iPhone 6 Plus, I think, last Friday.
Great.
Yeah, so just a little side note, not for people in the audience, but we were waiting. We ordered a bunch of different ones, and they were backlogged and coming in, even though the testing has been going on iOS 8 for some time. Through the test versions, right?
Yeah, we've been using the development versions of iOS 8 for a while, but the actual devices, Apple doesn't let developers get that any earlier than the public does. So,
unless you go to a bar in the Silicon Valley and one of the engineers happens to leave their device on the bar or something.
Yeah,
there's been stories in the past. Yeah,
we weren't lucky this time with that.
Yeah. Anyway, other questions for Darren? Send them in now. I think you were also in the previous hour. You were in the Object Pascal stream, the Delphi stream room.
That's right.
And I don't know if there were any other questions that came up that were different over there versus in here.
No, a lot of the questions were similar. One of the biggest questions has been about the native controls and what our future plans are with that. And like I said earlier, we have a pretty good architecture that we plan and want to roll out to more controls and more devices. That's kind of a long-term, multi-year project to do that.
Mm-hmm. And again, I always remind everybody, take a look at all these services, interfaces. I've done some blogs, and there's documentation about using and querying the services yourself.
Right.
FireMonkey does the same thing, right? When it starts up, Darren?
Exactly. When FireMonkey starts up, it takes a look at what services are available, and that determines what things it can show.
And then if a service isn't available, let's say a mouse service on an iOS device, and you've got some mouse code or something happening like on mouse down event, they just don't fire, right?
Right, exactly.
Yeah, it doesn't crash or raise an exception, just certain things don't work. And so think multi-device, think the device development. They don't have menus. There's different ways you can do button bars, control bars, other kinds of things, slide out boxes, and so on.
Yeah, that's the thing, and why we made the platform services have the query mechanisms, so that in the components that we've written for FireMonkey, we query the platform service, and if the service is not supported, then the component responds gracefully. It doesn't crash. It doesn't make assumptions that something is there. So for any of you that are writing components, that's the model that you should follow as well. If you need some service from the platform, query the service. If the service is available, then go ahead and use it. If it's not available, then it should gracefully go to a inert state or a different form of behavior.
And you can also query the platform you're on. So if you're on Windows and OS 10, you might want to do mouse-based operations and have menus and things of that kind.
Sure.
And then if not, you can have other code to create whatever your equivalent might be for yourself of like a slide-out box menu or the tabbed items for certain platforms. So again, you have all those capabilities by querying the platform, the version of the operating system, and other related events.
Yeah, exactly. Yeah, we have one of the new services, the iDevice Info service, that'll give you a lot of information about the device that you're running on.
Okay. So, and I guess is the T-Platform class, is that still around? T-Platform is still there?
Yeah, T-Platform is still there.
Okay. And anyway, Darren, thank you very much.
Sure, you're welcome.
Great to have you with us. And again, Darren is part of the team. They're building all this great stuff into FireMonkey across the platforms. So stay tuned for even more. There's always going to be new devices, new resolutions, new form factors, new components in the sensors and other things inside of these devices. And the team is on top of it.
Yep, exactly.
Okay, everyone. We'll let me switch back. Thanks, Darren.
Sure.